Welcome to the SWS webinar series. We are so glad you could join us today and hope you enjoyed our new intro section that will help cut down on some of our announcements. My name is Jody Murray Burns, and I am pleased to moderate this webinar and share an SWS e-learning experience during a time when we're all looking for virtual opportunities and to keep up with some of our continuing education credits. This webinar is one way to stay connected to the wetland community during this pandemic, and we hope that everyone is doing well. Next slide, please. Welcome to the third lecture in the 2022 SWS webinar series. Today's lecture and topic will be Restoring Coastal Plain Streams Functional Uplift through Baseflow Channel and Valley Restoration. It is my distinct pleasure to introduce our speaker today, Nasrin Dahlgren, one of our own certified professional wetland scientists and a certified floodplain manager. Nasrin is a senior project manager in the Bureau of Watershed Protection and Restoration within the Department of Public Works of Anne Arundel County, Maryland, where she manages large-scale stream restoration projects in the Patuxent and Magothy River watersheds. Her focus within the program is to utilize a watershed-based approach to restoring degraded stream systems to improve the function, habitat, and water quality within local waterways throughout the county and ultimately the Chesapeake Bay. Nasrin earned a BS from Frostburg State University in Environmental Analysis and Planning and a Master's of Geographic Information Systems from the Pennsylvania State University. Prior to her service in local government, Nasrin worked in private consulting where she managed and conducted environmental resource studies related to wetlands, waterways, forest and plant community structures, as well as comprehensive floodplain modeling and hydrologic studies. Thank you, Nasrin, for presenting today, and I'll leave it to you.
Thank you, Jody, for the warm welcome. I'm Nasrin Dahlgren, and I am very excited to be here today in this webinar series for the Society of Wetland Scientists. I wanted to first take a moment and acknowledge all of your work and dedication to wetlands and streams wherever you are located. And everything we do together, it strengthens the resilience of these unique systems, especially with regards to pollution, degradation, public health, and climate change. Your work matters, so thank you. And let's begin. Sorry, I'm flipping slides here. So we're going to focus on Cat Branch stream and wetland restoration and how we restore coastal plain streams. So I wanted to begin with a point of reference. Anne Arundel County is located in the Mid-Atlantic coastal plain, in the coastal plain of Maryland. We have over 530 miles of shoreline, and our rivers directly interface with the Chesapeake Bay. In 2009, President Barack Obama, through an executive order, dedicated the Chesapeake Bay as a national treasure, being the largest, most diverse, and biologically productive estuaries in the world. So this inspired deepened commitments from organizations and local governments and state governments for continued action in improving water quality and ecosystem health for the Bay. A little geography of Anne Arundel County, some facts. It's 588 square miles, 530 miles of shoreline. We have over 500,000 people in our population. We receive 40 inches of precipitation annually, 1,784 miles of streams, and 16% roughly of impervious developed surfaces. And we have 13 major watersheds and 80 named creeks and streams. The Bureau of Watershed Protection and Restoration is a bureau within the Anne Arundel County Department of Public Works. We're responsible for the environmental assessment, ecological evaluation, restoration, implementation, and all the work associated with the county's clean water obligations under its municipal separate storm sewer system permit. And this is assigned to larger, medium and large jurisdictions and also as part of the Chesapeake Bay total maximum daily load. And you can think of that as a pollution diet, so to speak. And this is all required by the Clean Water Act. And these figures are based on models created by the EPA. The Bureau of Watershed Protection and Restoration, we have a dedicated revenue source through our Bay restoration fees, and they're approved on an annual basis, and they provide funding for our capital projects. And looking at these photos, these are a lot of the challenges that we face in the coastal plain tributaries. On the left here, this is me, and I'm contemplating the severity of the erosion and the disconnectedness of this stream to its floodplain. And it's from a result of past land use practices. In the center, there's more erosion and failing of infrastructure. We see that very commonly in our streams. And on the right photo, another issue that is very common is fish passage issues, which we hope to provide mitigation for through our stream restoration projects. So much of the issues that you viewed in the previous slide, it's all directly related to stormwater. And every time it rains, all of the water is running off on the impervious surfaces. It drains directly into the streets and the associated storm drain systems. And those are directly inputting into our local waterways. And carrying with that runoff are all kinds of trash, pollutants, toxins, oils, and it's all left untreated. So it's a significant source of pollution to our waterways and our focus. And because of this, all of our waterways in Anne Arundel County are considered impaired because of these excessive levels of contaminants. And ultimately, all of these storm drains lead to the bay. So we want to address these issues where they begin, and because they ultimately end up in our local tributaries, which interface directly with the Chesapeake Bay. And the pollutants of concern that we are directly focused on at this time are sediment, nitrogen, and phosphorus. So what's being done? Anne Arundel County must meet their federal and state permit requirements to achieve nutrient sediment reductions. So what the county has undertaken is prioritizing what projects are to proceed based on very detailed watershed assessments throughout the 13 watersheds that are within the county. And our focus is on stormwater pond retrofits. And those are existing facilities that are typically some kind of dry pond that has either failed or is just simply not meeting water quality volume requirements to current standards of today. And we focus on stormwater outfall stabilization. And what we see here are the storm drains that drain directly to our waterways are severely eroded or in need of repair. So we want to stabilize those, prevent the sediment from entering the floodplain and the associated stream system, and just reconstruct that into a more functional tie-in for water quality and habitat benefits. And lastly, there's stream restoration. So here's where some of the largest contributors of sediment and phosphorus come from in our local waterways, from the bank erosion that you saw in some of the previous photos in the slide. So by restoring these degraded streams, we will provide significant benefits to water quality, to flooding, and ultimately provide ecological benefits. So this webinar will focus on the Cat Branch Stream and Wetland Restoration Project. It consisted of 1,500 linear feet of stream and wetland restoration. It consisted of stabilization and integration of 2 intermittent channels and the retrofit of a stormwater pond that was existing nearby in the neighborhood, and also repairing an exposed sewer line. The project's located in the Magothy River watershed, and it's roughly 35 square miles and a mix of urban, residential, commercial, and forested land use. And it's a part of our Chesapeake Bay TMDL that we're focused on for nitrogen, phosphorus, and sediment reductions. And we take a watershed-wide approach when we are evaluating and programming these stream restoration projects. So our drainage area in Cat Branch was 284 acres and roughly 24% impervious area. And it's primarily, the land use is made up of woods and residential land uses. So the targeted benefits and goals for this project, this is very much typical of a lot of our projects where it's practical. In this specific project, we were looking to promote denitrification during Baseflow, floodplain and wetland reconnection and reestablishment, and an enhanced hyper exchange flow, flood flow storage and reduction. We were looking to enhance stream and riparian ecological functions and improvement of aquatic and terrestrial wildlife. And additionally, impervious surface treatment and nutrient reduction. So this is a little bit of a walking tour of what the project extents look like. And this is the upstream area immediately upstream of the project. And you can see on the left and the right, the channel is fairly small. It looks like it can have access to the floodplain, especially here, very small channel. And we wanted to model this as our reference point because we want to have a channel that has that connectedness to its floodplain. The downstream conditions for the project, and this is immediately downstream of the project work area. And we had a culvert, and that there is setting our invert elevation and that water surface elevation in the downstream. And also we had a beaver who was further indicating what the water surface elevation is going to be in the downstream area, which was quite exciting and fascinating to have this be part of our downstream area. So on the right, you can see the wonderfully inundated system with lots of shrubs and wetland inundation shown there. So the next phase of the project is to delineate all the resources that is contained in the project area. We look at all the wetlands, identify what the classification of the wetlands are, what the stream classifications are, whether it's perennial, intermittent, ephemeral. We are also looking at the forest community structure. We're looking at the density and the types and the strata of these forested communities and documenting it for our initial purposes. So we were starting with about 2 acres of wetland and 2,000 linear feet of stream throughout the study reach. So for the purposes of this assessment, for the design, it was divided into 5 reaches, R1 through R4. And it also includes the reference reach, which you saw the photo of in a previous slide. And then geomorphic assessments were conducted for these project reaches. And that included a longitudinal profile, cross-section surveys, substrate analysis, and then also bank erosion assessments and mapping was conducted as well. So another further walking tour of some of the existing conditions that were referenced in each reach. This is representative views of what we see: channel incision and bank erosion. We have undercutting banks here on the right, and also there's property that's right nearby there as well. We also had a relic farm pond embankment, which was breached. That was creating a lot of erosion issues as well. And then also throughout the project area, we observed various debris jams and head cuts throughout this stream channel. Also, we had, unfortunately, exposed sanitary sewer infrastructure. And the photo on the left, you can see there's already a log laying on it. And I mean, it was just suspended over the stream channel itself. It was basically one tree or storm pushing debris through to have a potentially catastrophic failure of this sewer main. And also here on the right, we have this exposed sewer lateral as well, which could ultimately eventually end up like the one on the left if it was not addressed. But our team worked very quickly to develop solutions for all of these issues. And we worked in collaboration with our Bureau of Utilities to really mitigate this in an expedited manner, but also providing the ultimate goals of our stream project. So here's the Rosgen classification. These are just determining the different dimensions at the various reaches. I won't go through all of these, but it'll be available in the slide for future reference. Generally speaking, we were looking at F and G channels, which are fairly common classifications in degraded stream systems, meaning entrenched and just a gully type cross section. Here is showing a stream functions pyramid, and it's a framework used for stream assessment and restoration projects. And this was utilized through the project process to ensure that we're selecting the design approach and meeting the overall goals. So level 1 is hydrology, and that's looking at the runoff. What is the flow regime? Is it flashy? And level 2 is hydraulics, and that is related to floodplain connectivity and the flow dynamics of the system, looking at the bank height ratio and how eroded it may be. And then level 3, geomorphology, that's looking at the riparian vegetation, that's looking at the bed form diversity, and then how is the lateral stability of this system in its existing state? What is the erosion rates happening? So level 4 is physiochemical, and that's all of the nutrients, organics, dissolved oxygen that is assessed there via laboratory. And lastly, we have our biology, which is our fish communities and macroinvertebrates. So all of that was evaluated up front in part of this analysis. And here, fortunately, at the county, this site had been studied back in 2007 within this area. And you can see with the graph shown here, the cross section, on the blue line, you can see that that's the cross section of the stream. And then this same cross section was reviewed and measured in 2016. And you can see that there is clearly more downcutting of the system and erosion that's occurring. So we were fortunate to have that data up front for our purposes. This is the overall function-based assessment results. And what we're looking at is basically all of the R1 through R4 were coming in as not functioning. They were not functioning for any of those levels that we reviewed in the framework. Our proposed stream restoration design, we're looking to raise and narrow the existing Baseflow channel, and just to reduce the incision of the channel, and then connect it to the floodplain and raise groundwater. And we do that using backfill and clay channel blocks, which I'll go into a little later. But I think what I really want to mention is that, this wasn't based upon a bankful channel. We're building low flow channels that will flood at any rain event. Anytime it rains, it's going to access the floodplain and hydrate the floodplain at every rain event. So that will increase roughness and reducing shear stresses by having that access for the flood flow within the valley. We also try to modify and create a more sustainable plan form, and increasing the sinuosity in some places where it's necessary, maybe reducing it in other areas where it's too much curvature. And then of course, reducing the channel slope to retain the time that the water is in the system. And then looking to reduce the curvature and the shear stress of the system. So we also incorporate grade controls where necessary, and the such items as the boulder weir that was really put over the infrastructure to protect those sanitary lines. Also log cobble riffles, the use of valley-wide grade controls to mitigate the shears across the floodplain. And we incorporated microtopography features and micro pools and large woody debris. And then at the bottom, I just showed what some of these discharges are for the design. So here's just a conceptual design that we originally planned out. And this just goes through some of what we wanted to do to attain our goals. And, filling the channel, stabilizing the head cuts, creating stable tie-ins for the outfalls that drain to the system, also smoothing the existing meander bends. And additionally, proposing where the physical log structures would go. And here's another view of that for the downstream area, removing the weir that was in place and the berm from the relic farm ponds, and again, raising the channel, creating a stable tie-in to the downstream area that's already controlled by the invert elevation of the downstream culvert. Next, as part of the analysis, we are using 2D modeling to evaluate, based on an elevation model, evaluate our design and inform our design. So this is a powerful tool that has been being used by our engineers to come up with the best solution to achieve our goals. And what you're seeing here is the 1-year storm event depth, and this shows the incised channel, shows how incised it is. This is the channel here prior to restoration. It's not accessing the floodplain at all. It's just going down the channel and not retaining any flood flow at the 1-year storm event. This is the proposed conditions and the half-year storm event. And you can see that it's really accessing, I jumped to this 2-year, but they're very similar. And they're accessing the floodplain quite nicely and quite similarly for both of those. But the 2-year is slightly more inundated at that event. So here is the proposed conditions for the 100-year storm. And this is the maximum inundations depths that we've accounted for. And that's just showing the entire valley is completely inundated at this storm event. Here is, I'm hoping this can play because this, just bear with me 1 second, please. There we go. So this is the 100-year event storm video, and that's just showing the full, let me see if I can get that to play again. Oh, there we go. Bear with me 1 second. Have the Zoom. There we go. Sorry, the little button is in front of where the play is. Now I found it. So you can see that completely inundating the valley for all of the storm events up to the 100-year. So really cool tool to use to inform our designs. And here is a view of the 100-year shear stresses. We had very high shears in these red zones here. And also here where this outfall was entering the floodplain. So that helped inform where these grade controls should be located and where, because we want to make sure that there's not erosive things happening in the valley. Here is the function-based assessment for the proposed. So we started out with not functioning for level 1 through 3. And for the proposed condition, we are functioning at risk for hydrology and then functioning for level 2 and level 3. And that was our design framework. Now, I know this scale might be a little difficult to see, but I just wanted to give everyone an overview of what our plan sets look like. And this is just one of the sheets of our grading plan. And it's showing the limits of disturbance along here and here around the project. And these are just some of the features here. This right here is a structure Here's a valley-wide grade control. Here is another log cobble riffle, valley-wide grade control, clay channel blocks, another valley-wide grade control. So you can see how we have situated this throughout the valley based on the design and the hydrology and hydraulics that have been analyzed through this process. And these, if you are interested, these are on our webpage, and we'll have that information later, and that's accessible for viewing from our Anne Arundel County website. Our projects need authorizations, and that's typically all of our local, state, and federal permits, our joint permit application through Army Corps of Engineers, Maryland Department of the Environment, grading permit from our local Anne Arundel County Permit Center and Soil Conservation District, and also a notice of intent for construction activities through Maryland Department of the Environment. Also, a big part of this is easement acquisition and floodplain dedication, and that takes a lot of effort and buy-in from community groups, HOAs, and individual property owners. So things we consider during construction, equipment access and noise to the surrounding community. In this instance, the downstream beaver activity. Also working and excavating near utilities. We have to be mindful of that at all times when working near this infrastructure. Also working in an active stream channel, working within wetlands and a floodplain that's active. So we're being sensitive to what that is, and like with the use of matting, which you'll see later. And erosion and sediment control. And we monitor that daily, and we want to make sure that there's not any dirty water leaving the site. We want to make sure all of our sediment controls are maintained, and that we can get in and get out very quickly to cause the least amount of impact to the resources and also the surrounding community as well. So here's just a view of the access and matting that is used. We had very mucky soils, as you can imagine. And this just creates a stable platform for the equipment to work within. And here we have a clay channel block. This is a detail directly from the plan set, and basically it's a trench that is dug out and filled with clay, compacted, and then backfilled with borrow or salvage material from the stream, or salvage topsoil. So we use that a lot to help promote the groundwater, and also directing if we had to move the direction of the stream channel, if we were reducing the curvature per se, then we would put something like that in place to kind of guide it into where we're planning for it to go. And here's a view of the log cobble riffle that I described. This is also on our plan set. And here it's basically a riffle bed stability mix that is has varying sizes of stone. There's some logs that are trenched in and supported with anchor stakes. And it's also sloped to have a more gentle slope, and that we can retain the water in the system for as long as possible, not creating any erosive forces or any blockages in the stream. So that's all thought out very carefully in our design. Here's a view of that, the install of that. So you can see on the left, there's the trench, the log, and these are typically spec'd at 24 inches, and if they don't meet that sizing, then it could be doubled up. But this one in particular was anchored into place with larger limbs and then backfilled again. So here's a view on the right, and that's the two, one there, one there. Hopefully you can see my pointer. And you, so that's what it looks like immediately after it had been installed at the invert elevation that it was spec'd out for the stream. And here's another thing that I'm very adamant about is washing in of the various materials. We want to make sure that the bed material mix is incorporated. We want to make sure that the larger material is all the voids are filled in, and it will fill in all those void spaces and really lock it into place, especially during the sensitive times after it has been constructed. So I've seen it done other ways where it's just tracked in with the equipment, but I think I prefer seeing it washed in because you can actually see those particles like dropping down in and getting down into the larger material that's being put in place there. So that's a little demonstration. So the value grade control, that is very similar to the previous log grade control that we showed, except these span the entire floodplain. And sometimes they'll have to be overlapping so that it can meet that length that's required. So it's installed very similarly to the log Cobble Riffle. But those are what those views look like in our details. So here's a view of that. And you can see off to the left, that's where one was put in place, and all those stakes with the orange flagging on the left, that's where it extended out to. And they were just, the contractor was making sure that those grades were meeting the requirement of the plans. So, and it also extended off to the right, but you can't see it because it's subsurface, but it's there. And then additionally, we add the microtopography and large woody debris throughout the floodplain, and that just creates roughness in the floodplain. It creates areas where habitat can flourish, and we like to incorporate that, and we also spec that in our plans so that contractors will know that that's what we're looking for in our floodplains. And here is an incredible drone shot by Bayland. And they, this is showing on the left, you can see that microtopography on the left, lower left of the photo. And then on the lower right, you can also see some of that woody debris that's scattered in the floodplain. And then there's our channel. It's full. So when the next rain comes, it's going out on the floodplain. So this is shown immediately out of after construction. It hadn't been planted yet. Here's another view. Same thing, hadn't been planted yet, but nice pockets of wetlands, microtopography, braided channel system, which we like to see. So additionally, we plant our projects, and we go for a 1-to-1 ratio. That's our requirement, and we try to go for more than that. But in this case, we had to modify our plan slightly because of the extremely wet conditions of the valley. It turned out that it was staying inundated and not drawing down as quickly as we had anticipated, but it was great because we just expanded the channel fringe plantings to a much larger area, ones that are adaptable to those inundated conditions. So we planted over 600 native trees and shrubs and a beautiful native seed mix and also 1,000 live stakes that included black willow, which I hope the beaver downstream will be enjoying. Also, what really excited me was the native seed bank that exists within the salvaged soil. And I mean, the photo on the lower right just excited me so much, because here it is, skunk cabbage during construction, growing up through our construction haul road. And we hadn't even finished construction yet. And it was just so exciting to see that already flourishing. So here's the picture on the left, is that that native seed bank merging in with our planted materials. And the photo on the right is one of our live stakes that was planted, and this was probably the fall after this was planted. So only one growing season, and they are like 4 feet tall now. So that was very common and great to see the vegetation filling in. And these are just a few of the common species we planted in the channel fringe and floodplain. We also had upland species, but those are the wetlands we were focused on. And here on the left is post-construction. Immediately, and this is the photo on the right is a similar view after a growing season. So you can see it just really filling in with beautiful sedges and rushes and lots of great wetland material, and then our planted material as well. Here's more views of the floodplain. I think you might have recognized this house on the photo on the left of the house. That was where that channel was just deeply eroded. And here is more photos of the floodplain on the right and lower right. More views of the riffles in action. The one on the right was right after a tropical storm. So that held up very nicely. You can see the grasses are just totally matted down, and it held up great. And that was during its first year, its very first growing season. And this is just a lovely photo that I just enjoy. You see the woody material, the inundation, all of the wetland plants. So I'm excited to see this one flourish and evolve over time. And it's very exciting to witness. And this is really, hopefully I can get this one to play. I'll just, this is the time lapse that was given to us by University of Louisville. And it's just a great picture of the project through the seasons and through the storms. So it's so interesting to see that and observe in this manner. So there you have it. And another mosaic, georeference mosaic that was provided to us as well. And we'll be using this in our analysis as for post-construction monitoring. So our nutrient load reductions were 783 pounds nitrogen, 58 pounds of phosphorus, and 40 tons of sediment on an annual basis. So we were excited about that. And in summary, we are at Anne Arundel County Bureau of Watershed Protection and Restoration. We are building Baseflow low flow channels that access the floodplain, create wetlands, and we're using these 2D models to inform the design. We are placing grade controls as necessary. We want to restore connection to the floodplain and to enhance our wetlands. We want to create habitat and remove pollutants, and importantly, improve the bay, our local and national treasure. So here's our wonderful project team, all the staff at the Bureau of Watershed Protection and Restoration. Lots of folks had their have helped with this tremendously. Bayland Consultants, they were the lead designer engineering firm on this project. We had PayDirt, who was our construction contractor. They built this, this stream restoration. GHD was our inspection team. And then also Maryland Department of Natural Resources, they, their generous partnership and funding for this project through the Atlantic and Coastal Bays Trust Fund grant that they gave us in 2019. And we also couldn't have made it possible without the support of the surrounding community. So just some project news. This project won the Honorable Mention Award for Best Stream Restoration in 2021. And that was through the Chesapeake Stormwater Network, the BUBBA Best Urban BMP in the Bay Award. So that was very exciting for our team. And also the University of Louisville is conducting research under Dr. Art Parola. And they're evaluating the actual 2D models that we're using to inform these designs. So it's really, will be incredible to follow what that work, what the results are of that. And then new research is coming through the University of Maryland Center for Environmental Sciences, Professor Robert Hildebrand, and our Bureau of Watershed Protection and Restoration staff. And they're evaluating environmental DNA for biological monitoring. And they're going to look at new ways of sampling these restored sites that will compare them to the traditional ways of sampling and compare those two and see, what kind of biological uplift there is. So it's very exciting. Keep your eyes open for that exciting research that will be upcoming. Thank you.
Thank you, Nasrin. That was a very interesting presentation. We're going to move into the Q&A part right now. Again, I'm posting your questions and some of my own perhaps that I've received through the Q&A button to the presenter. I may need to check some that ended up in the chat box.
Okay.
But let's go ahead and get started. Let's see. Justin Wagner asked, how do you quantify sediment reductions for MS4 credit when stabilizing a stormwater outfall? Do you have any insight?
There are several protocols, and I understand, I believe we did protocol 5 for this one. I would have to check. We have an entire team of staff that's dedicated to this specific, these specific calculations. If you need more information, you could go to our website, which is listed there, aarivers.org. And I'm certain that there are a lot of resources that we could point you to if you need a further assistance on that.
Thank you. Jeff asked, can you give us an idea on total cost of the restoration for this size of watershed project?
Yeah, this project was roughly, I want to say it was $1.5 million total for the stream, all of our plantings, inspection, design, our county expenses, because we have expenses too. So yeah, we look at maybe about, for construction, around 600 to 700 a linear foot, but that's just for construction.
Do you have any numbers on the easements? Were people paid for the easement to be able to do the project?
For this one, we did pay for easements. I can't recall the exact amount, but yes, the county, we also have a team of experts in that right of way, and they will evaluate via title work what that land is worth, and then we go from there. We offer compensation for that in most cases.
All right. Greg No asks, were there stakeholder concerns about mosquito habitat and how did you address them, if there were?
Oh, yes, we always have concerns regarding mosquitoes, but we, through our outreach, we commonly discuss with them that a lot of the mosquitoes are breeding in their own gutters, their own flower pots, things like that you find around your yard, and it may be their neighbors that are really, contributing to that. We like to tell them, we have resources also on our website for that, the same topic, but a system such as this would provide so much habitat for other wildlife that would eat these insect larvae. And, it's all part of that ecology. So it's, we don't really see a lot of issues in our stream systems at all. It's typically within the residential areas, and it's directly related to some of the issues around the homes.
Ryan Hammonds asked, did you consider the low-tech process-based restoration technique, if you're familiar with that?
Low tech, if you do you mean like beaver dam analogs and things like that? If so, yes, we always consider all of these types of techniques. And I believe that when you saw the shear stresses that were coming through the valley at that 100 year, I'm just, what we felt was the best solution was the log grade controls throughout the entire valley because of those high shear stresses. So I don't know if that would have been the most appropriate in this particular instance. But yes, we do consider them.
Thank you. Katie Scott was wondering, during your post-construction monitoring, what control mechanisms do you have planned to control invasives?
Good question. I don't have a SOP written up for that at this time, but we do have resources in the county that we engage local. We have a local program called the Anne Arundel County Weed Warriors, and they, we would engage them, and they seek volunteers, and we have that tool, to provide for that. We ourselves are not certified in spraying and things like that. So it would be something that we would have to evaluate in the future.
Okay. Steve Harrod asks, what is the expected lifespan of this project once it's completed?
Oh, I mean, we're expecting it to just evolve into its own ecosystem that ultimately sustains itself in perpetuity. We feel that these are the way that the floodplains should interact with the streams, and with the beaver living there as well. That's fostering a mutual beneficial environment there. So we're hoping that, when the vegetation grows in, it will just continually evolve into its own ecology.
Okay. Another person asked, has there been any monitoring of functional uplift during the permit compliance period?
Yes, we completed that, and we basically are looking at the stability of the structures that have been installed, and that was recently completed, and we found that it was functioning as intended. And as part of, I think I had mentioned, there's going to be further monitoring for the biology that is that involves our staff and the University of Maryland. And that's going to be kind of like a pilot project of, they're focusing on that particular stream. So
Okay, so in general, if I understand and followed what you were saying, there's multiple parties responsible for the post-construction monitoring. I mean, you may do one part and someone else is doing another.
Well, typically we're responsible for it. We have the easements. It's our responsibility. So we will do the monitoring unless we have contracted it out to someone else, to a firm to do that. But generally speaking, we're doing it in-house, at least what I've done for this project.
Well, I think that's all the time we have for questions. If you have any ones that need or you want to follow up with Nasrin, you can see her email address right there. She's generously said she would answer any more questions. If you could reach out to her directly. We want to thank our 2022 sponsors of this webinar series. We have Whitman Group, WildNote, Delta Land Services, and In Situ. Please visit, like, and follow our SWS webinar sponsors. And I wanted to bring to everyone's attention the next month's webinars that will be presented. Our next English language webinar will be March 17th, 2022 at 1 p.m. Eastern. We'll be joining Jonathan Barmore of the New Orleans District Corps of Engineers for a presentation on approved jurisdictional determination requests and the status of the waters of U.S. definition. That should be of interest to quite a few of us. The next Spanish-speaking webinar will be March 23rd at 1 p.m. Eastern with Dr. Constanza, who will be speaking about hydrologic model of sediment transport, a tool applied to recover and manage Santa Marta wetlands in Colombia. Please check out our website and social media channels to learn more and register for upcoming events. And don't forget to complete the survey that will be sent to you after this webinar. So you'll receive a certificate of participation and be able to provide some feedback to us on this webinar series. Thanks again to Nasrin for such a great presentation, and to our audience for your questions and participation. Have a wonderful day, and everyone stay well.
Thank you so much, everyone.
Bye.